My dear students, today I will discuss about an important topics which is not only included in the B.Sc syllabus but it is important for any competition examination. Today's topic is neighboring group participation. Now I shall discuss about neighboring group participation. Before discussing these topics, I will go through a question. What do we know from the knowledge of SN1 and SN2 reaction? Number one, in SN2 reaction, leaving group differs by the assistance of nucleophile, and in an SN1 reaction, it is not. Number two, these two types of reactions are distinguished by their order of reactions. Number three, SN1 reactions follow first order reactions, whereas SN2 reactions are second order. SN2 reactions takes place with inversion of configuration, while SN1 occurs with racemization. For NGP, what change are there? Now this is the question. NGP follow the substitution reactions which are first order. Here first step is rate determining step. It involves two successive SN2 reactions. A carbon atom that holds the leaving group is attacked from backside. The final product retains its initial configuration of the reactant molecule. So, how can we define NGP or neighboring group participation? The interaction of neighboring reaction center with a lone pair of electrons in an atom or the electrons present in sigma bond or pi bond to form a product with retention of configuration is called neighboring group participation. Now, what is the mechanism for this reaction? True SN2 substitution takes place for this mechanism. Step 1, attack of internal nucleophile. Here, the neighboring group containing the lone pair, it attacks to the carbon center which hold the leaving group, and this leaving group divert to form this product, and where Z is the neighboring group and here X is the leaving group. Step 2, substitution of external nucleophile. What happens here? Y as the nucleophile attack to this center. This is the cyclic intermediate, and nucleophile attack this center to break the cyclic intermediate to form the product. So what are the special characteristics of neighboring group participation? This is the first order reaction. It proceeds via SN2 mechanism. It involves two steps, where first step is rate determining, leading to overall first order kinetics. In NGP, the intermediate has a cyclic structure, which may lead to a normal, rearranged, or cyclic. Nucleophile must be in transposition to the leaving group. And stereochemistry for NGP reaction is the retention of configuration. And most important point for NGP reaction, enhanced reaction rate. That's why Due to this enhancement of reaction rate, it is also called enchimeric assistance. Which reactants will participate in neighboring group participation? This is the important question. Reactant molecules having the following criteria may participate in NGP. Any group that possesses an unshared pair of electrons or a double bond or electrons present in a sigma bond or pi bond can participate in neighboring group participation reaction. Which groups will face, facilitate the neighboring group participation? Some of the groups which can facilitate the NGP, these are COO minus, COOR, where R is alkyl group, COAR, aryl group, OCOR, R is alkyl group, OR, OH, O minus, and these groups. These groups can facilitate the NGP reactions. The most likely neighboring group participation leads to 3, 5, or 6 member ring. Now, what happens during the reaction? The electron density will accelerate the rate for departure the leaving group. That is the magic of these reactions. So, what important points should be remembered? Adjacent carbon atom containing lone pair of electron participate in the NGP reactions. This proceeds via SN2 mechanism and new cyclic reaction intermediate formed during the reaction. Nucleophile must be in transposition to the leaving group. Now, what unexpected occurrence that happens for the NGP reactions? Number one, unexpected behavior, retention of configuration. And second, unexpected behavior is first order reaction. We will discuss some examples regarding the NGP reaction. First of all, the NGP by the heteroatom lone pair. That means heteroatom contains lone pair that remains as the neighboring group and participate in neighboring group participation. Although mustard gas, one of the glaring example in this point, mustard gas. Although mustard gases are primary halides, but the rate of reaction is much higher for the sulfur mustard during hydrolysis in water, which is a very poor nucleophile, than it would be for a primary alkyl chloride not having a heteroatom. Now, this is the hydrolysis of mustard gases to form this product. And what is the mechanism behind this reaction? Now, we'll go through the mechanism. Here, sulfur atom containing lone pair electron attack from the backside to the carbon atom that hold the chlorine atom. This to form this cyclic sulfonium ion. This step is very slow, and this is the rate determining an internal SN2 reaction. And in next step, the water molecule, lone pair of the water molecule attack this center of the cyclic intermediate and to break the bond to form this product. After the departure of hydrogen, this product is formed. NGP of ether oxygen in the cyclic compound. Now, for these 4 cases, A, B, C, D, D reacts almost 4.84 into 10 to the power 4 times faster than A. NGP by lone pair of oxygen facilitate the departure of leaving group. Stable 5-membered ring is formed in the case of D. Now, coming to the point, NGP by pi bonds. The pi orbitals of an alkene participate in delocalization of positive charge of the carbocation, and in this way it stabilizes the transition state. It has been observed that unsaturation tosylate reacts 1011 times faster in aqueous solution with a nucleophile than the saturated tosylate. The carbocation intermediate formed during the reaction is stabilized through the resonance and positive charge spreads over the several atoms as follows. The reaction also takes place in the same manner even the alkene remains in far distance from the reacting center. In that case, the alkene will also able to delocalize the carbocation. Now NGP by aromatic rings. Here is a picture where NGP through an aromatic ring occurs. If we consider the reactivity of benzyl halides, it is highly reactive because the SN2 transition state gets an overlap effect to that in the allyl system. An aromatic ring can form a carbocation intermediate which is called a phenonium ion and it is also stabilized due to delocalization of the positive charge. Okay, this is the example in this regard. Now the NGP by cyclopropane, cyclobutane or a homoallyl group. If cyclopropyl methyl chloride reacts with ethanol and water, a mixture of 48% cyclopropyl methyl alcohol, 47% cyclobutanol and 5% homoallyl alcohol that is but3-enol is produced. The intermediate carbocation is stabilized due to spreading of positive charge on many different carbons through a reversible ring opening. Okay, this shows the fact. Now neighboring group participation on SN2 reaction. In nucleophilic substitution reactions, neighboring group participate primarily in the form of intramolecular nucleophile attack followed by intermolecular substitution. Okay, from this we can understand the fact the stereochemistry developed in the substituted product is the retention of configuration by opposing the inversion of configuration which is typically associated with the SN2 mechanism. Now about the reaction we should know something what happened during the reaction. The reaction proceeds via two steps. Step 1, the neighboring group acts as an internal nucleophile. It attacks the substitution carbon center that is SN2 attack and leaving group is lost to give a bridged intermediate. And step 2, the external nucleophile attack from the backside. And what will be the stoichiometry of the reaction? As a result, in an overall reaction, the retention of configuration is observed. And if the kinetics is concerned, as the first step is slow, and so it is considered as rate determining step. Hence, the reaction follows first order kinetics, and there is no effect of concentration of nucleophile on the rate of reactions. And the thermodynamics involved in the reaction, we should know why the reaction rate is increased so much. During the progress of reaction, reactants become less free in the transition state than the former. Hence, due to decrease in entropy of activation, reaction rate increases. It has been observed that in NGP reaction, the rate of reaction enhances by several order magnitudes. This is why this type of reaction is also called enchimeric assistance. Formation of cyclic iodonium intermediate. Beta halogens, that is one carbon far from the living group, are a very common example of neighboring group participation, forming cyclic halonium ions with the reacting center. Chlorine, bromine, and iodine ions are considered for such type. Cyclic ions of this type are formed stereospecifically with inversion of configuration. Okay. Amides, sulfides, ethers, and alcohols also act the participating neighboring groups. There are more other groups like sulfides, amides, alcohols, and ethers also response in neighboring group participation. These groups also add stereospecificity to the reaction center like halogen. But these groups need not to be in the beta position in order to act as the neighboring group and can therefore form cyclic intermediates of rings of varying size. In addition to producing retention of configuration of the product, these groups also provide anchimeric assistance. Now, acetoxy group can also act as the neighboring group. Beta acetoxy substituents are also act as the neighboring participants and form five-membered cyclic species by bonding through the carbonyl carbon. The existence of acetoxonium ion has been supported by trapping experiments in ethanol to give 4. These trapping experiments were important in exhibiting that the reaction was not proceeding by classical SN1 mechanism. The reaction produces 3 proceeds with inversion of configurations, once again yielding an overall retention of configuration. Alkoxy group is a weak nucleophile, but it can function as the neighboring group, neighboring nucleophile. For this case, the solubilisis of isomeric P bromobenzene sulfonate star A and this is B leads to identical product mixture, indicating the involvement of common intermediate, a cyclic oxonium ion. Double bond of non-Bornenyl systems derivatives also act as neighboring group. It has been observed that non-Bornenyl derivatives also participate in neighboring group participation reactions via non-conjugated P systems. In this context, we may consider most famous example of P bond neighboring group participation is that of anti-7 non-Bornenyl derivatives. These derivatives were believed to participate through a p orbital interactions, though this interaction invokes molecular orbital explanations as opposed to the nucleophile nature of the neighboring groups. Still, the retention of configuration is observed in substitution products as seen with the previous example. In other words, one observed only anti-substitution with respect to the double bond. This is the example which supporting evidence was provided for this type of cation versus a rapidly equilibrating structure by Grassmann et al., who substituted one methyl group onto the double bond and showed a significant increase, nearly 13.3 times greater than the unsubstitution reaction. For similar substitution reaction, when they substituted a second methyl group onto the double bond, the rate increases was similar to that in the first substitution, nearly 148 times greater than the unsubstituted reaction. Hence, the stabilization of carbocation is dependent on both carbons in double bond. If the structure of carbocation are rapidly equilibrating between the two double bonded carbons, then we would have shown no rate increase by adding the second methyl group. Now, the important SN2 pathway is more favorable pathway with in which displacement of brosylate, which is the good living group, is possible for compounds like this and this, and this. And the internal displacement pathway leads to the formation of relatively stable 5 and 6 membered cyclic oxonium salts for this case. And as the chain length increases, the likelihood of cyclic oxonium ion formation diminishes and rates approach to that of the reference case where only SN2 attack by formic acid is possible. Neighboring group participation on SN1 reactions. There is two examples in this regard. The SN1 pathway leading to a primary carbocation intermediate is not as favorable as a neighboring group participation, which is an internal displacement pathway leading to an episulfonium ion intermediate. Now, neighboring groups and rearrangements. There are 5 cases that happens in this way. Number 1, case 1. From this picture, we can see the exobicyclic trosylate undergoes solvolysis reaction 10 to the power 11 times faster than that of the endoisomer. This occurrence is attributed to the assistance of pi bond for the formation of the carbocation, and the beta resistance is observed from the backside of the trosylate. Now, case 2, where from this picture we can see the solvolysis reactions for the trans trosylate takes place 1000 times faster than the cis isomer. Here, non-bonding electrons of the carbonyl group from the backside of the leaving group assist the formation of developing charge. Now, case 3. For this picture, in general, primary cation does not take part in solvolysis reactions, but neighboring groups can assist the solvolysis of primary substrate in a synchronous step to form a stable carbocation. Owing to donation of electrons of phenyl group from the backside, rearrangement occurs in beta phenyl substrates, which gives a stable cyclic phenonium ion. Now, coming to case 4. This is a very important example in this regard. Another primary substrate, the neopentyl system, rearranges rapidly to give the product. In this case, methyl group assists the formation of charge in cyclic ion to give the more stable tertiary carbocation and finally give the product. Now last, the case 5. But what can I see? It is very much important that it has been observed that vinyl cation, it can also take part in the solvolysis reaction. due to presence of good living group triplet. The phenyl group migrates to give more stable benzylic type ion. Now, I am coming to the summary of the overall neighboring group participation reaction. First of all, a neighboring reaction center with a lone pair of electrons in an atom or the electrons present in the sigma bond or pi bond participate in NGP. Secondly, it is the first order reaction. It involves two successive SN2 reactions. Neighboring groups having electron releasing property are more efficient to occur smooth reaction. For taking place the NGP reactions, proper orientation of the functional groups is a necessary requirement. The stoichiometry of NGP is finally retention of configuration. Here the reaction rate increases. That is also the important for the neighboring group participation. NGP occurs via heteroatom with lone pair, pi bonds, aromatic rings, cyclopropane, cyclobutane, or a homoallyl groups, acetoxy group, cyclic iodonium intermediate, amines, sulfides, ethers, alcohols as a participating neighboring group. Double bond of the non-bondinal derivatives can also act the neighboring group in the neighboring group participation reaction. In neighboring group participation, the intermediate has a cyclic structure which may lead to normal, rearranged or cyclic product. Thank you very much for your patience hearing.